Hi, welcome to this quick video on ZP micro pH sensors. So a couple of weeks ago I put out a video where I was actually talking about this data where pH sensors, whether from Zimmer Peacock in this kind of microelectrode format, this is a sheet of them by the way, whether it's them or whether it's glass or stainless steel barreled electrodes, they often show a change in potential as a function of time. But I was realizing that looking at some historical data over 16 hours, in fact what was happening was that most of the potential change actually took place quite early on. And so if you could think of strategies or mitigations, mitigations to deal with that early change in open circuit potential, which would reflect in a change in pH, deal with that, then overall you'd have a pH signal that was much more stable. So I kind of showed that, if you just did a sort of 1 point calibration, how the pH would go from 7 to 7.8, but by coming up with a pH strategy, by doing some calibrations, you could actually change or reduce the impact of open circuit potential drift, and therefore its impact on pH by doing a series of pH calibrations during the run. Now, I was trying to make the point at the time, and I think it's been picked up on that actually most of the pH changing is actually happening quite early on, and so then the questioner now has actually picked up on that fact, and what I'm going to do now is answer that question and kind of say, okay, does this mean that you need to recalibrate the sensor several times doing a bioreactor run? I don't think the answer is that you do. I think you can see the way that a pH sensor went into that solution, it changed its open circuit potential. But of course, what you say in your next question is, or having a 2 point calibration, pre-calibration, I'll actually do what you're doing, or I would play with some of the ideas that you have here, doing a 2 point calibration and then a pre-submerging. I would actually argue doing the pre-submerging and then the 2 point calibration is a good idea. So in the end, what WZP is demonstrating is that the pH sensor is more than stable enough, and I've never had that doubt to remain 16 hours in a solution. I've always known that was the case. Now the case here is you want to do continuous monitoring in a bioreactor. So now that you can see how a sensor changes over 16 hours, you have to then imagine strategies, and which is what you're doing in point 2. I think the idea of possibly just slightly shifting that maybe tactic rather than a strategy is do a pre-submerging, because I actually think that our own data shows you that after several hours actually the sensor becomes stable. So you get that sensor to be stable by pre-submerging, and I've got a suspicion that you only have to do this one time with a sensor. I've got a suspicion the next time you do it, you'll actually find that it stabilizes much quicker. Now I'm extrapolating slightly off many of our sensors, but many biosensors are made in anhydrous conditions. And so the first time they see an aqueous solution is the time that they undergo their most change. But the next time they undergo they get exposed to the aqueous solution, they've already done all the changing that they were going to do previously. So don't. So what I would say is your point 2 is a good point, but do a pre-submerge and then a 2 point calibration and then go into the reactor, and you'll probably find that fairly quickly on it will have stabilized. Now they're asking a harder question here for you, which is, can they print longer strips? Now the question is, can we make it longer? So at the moment, we manufacture in this kind of format, and we singulate them, and when we singulate them, we make them 26 millimeters long. Now you can understand that our pricing on our web store is a reflection of our manufacturing scale. So if we make these essentially twice as long, rather than making 300 sensors per strip, we actually make them 150 sensors per strip. So that actually means that the pricing that we have would more or less double. And that's making the assumption that we've done all the R&D and all the development needed to make those longer strips. So I just kind of think of it a little bit like this, that your application is the tail and the sensor is the dog. So it's a sort of I know it's a sort of an idea from, not an idea, but a sort of a metaphor from the English language. But I generally think, in this particular case, the sensor is the dog and your application is the tail. And we say, the dog wags the tail and not the tail wags the dog. So in this case, the sensor is the bit that's kind of stable and all the R&D's got into it. And you have an application. And it's really the application has to figure out how it's going to use that sensor rather than the sensor figure out how it can be applied into that application. Now, the reason I put that why is it hard to change a biosensor? So when we manufacture these things, we do have tools and machinery all set up to manufacture those things. So we've now been making this easily since 2019. So there's 6 years of effort gone into that. And it seems like a trivial thing to change the length, but we were all set up for it. Updating the product will definitely require retooling, which can be expensive and time consuming. See, it's not that we cannot make a longer sensor. It just comes down to this really, it is expensive and time consuming. It's hard for us because the way we do quality control, so all our rigs and jigs for doing quality control are all set up for this size, and so any kind of change causes an internal problem. Redesigns could change backward compatibility. Not that that existing customers will want this. Redesigning will increase our manufacturing costs. We don't need to redesign because we're actually selling this at quite high volumes. Now, but this last point is a really good one for me. See, a stable, mature product. So people are very keen in this world in going for customization, but a stable, mature product. We've worked out all the bugs and the reliability issues. So the way that we manufacture this, we've been doing it for a while. It wasn't perfect first time, but after several years, it actually gets quite good. So when you make even what you think is a small change to manufacturing, there's unforeseen consequences to it, and so it really just does come down to. If I restated the problem here, you've got this bioreactor, we've got this slightly short sensor, and you want to make, essentially, you want to fix the problem by making the sensor longer. This product is matured, it's invested in, it works. Even a simple change like making it twice as long, in the end it does come down to, yes, you can, but it is an expensive effort. The reason I put this silly picture of myself is to say, really think it through. How would you take the standard product that we have and make electrical connection with it? I understand the problem that, connections underwater, etc. So I completely understand it. But before you can have twice as long, I might ask the question, have you tried out the sensor as it is today? So in the end, it can be twice as long, but it is an expensive effort. And it's not because by the time you see the price on our web store today, that's after 6 years of optimization and getting things right. So quick answer is at Zimmer Peacock, we like people to, in the first instance, get the standard product. Then much later on, when they're well funded, start talking about customization. Customization, this is a slightly different route, but customization, if you're trying to commercialize a new product, doing it too early is a really bad thing because it means that you're having to cover all the costs of R&D, all the costs of manufacturing. You're the only person using that particular part number, which means very low volume manufacturing. Very low volume manufacturing actually means very low quality, but a high price. So I would say this is ZP is willing to do longer sensors. It is an expensive endeavor. I would actually ask you genuinely think about how you can use the sensor as it is rather than going the customization route. With customization, we can do it. It's just expensive. Now, if you do have any questions, and you can see that ZP really does think through the questions that come in, don't hesitate to reach out to us. Okay, thanks very much.